On the internet, there's a group of people trying to create a Leviathan Lobster God. The name Leviathan is depicted as a giant sea monster in ancient myths and literature. Founders of this lobster religion believe lobsters don't die of old age, but from the exhaustion of being too large to molt. They believe that by simply helping a lobster molt and grow to a massive size, they can finally bring the legendary Leviathan Lobster God to life. Well, that sounds hilarious. This meme actually has a quite solid scientific basis. The lobster mentioned in these memes usually refers to the Boston lobster. Theoretically, they do possess the ability to live forever, thanks to their cell's incredible potential for indefinite rejuvenation. But here's the big question. If both lobsters and humans are animals, why can their cells do it while ours can't? The key difference lies in a structure at the end of our chromosomes called telomere. Every time a cell divides, the chromosomes shorten, with telomeres at the very end acting like a shield to protect vital genetic information from damage. However, once these telomeres wear out, the cell stops dividing and eventually dies. When this happens to cells across the entire body, the organism reaches the end of its life. But cells actually have a hidden mechanism that can regenerate these telomeres. Simply put, it's a way to make aging cells young again. One common method involves a protein called telomerase. In human cells, this protein is mostly inactive. In contrast, lobster cells have incredibly active telomerase. This means as soon as their telomeres shorten, they grow right back. As a result, their cells remain perpetually young and keep dividing, allowing the lobster to grow indefinitely. This is exactly why lobster god believers are convinced that a lobster could eventually become an immortal creature. Throughout history across every culture, humanity has always yearned for this kind of immortality, and in 2025, we witnessed an epic breakthrough. An American biotech company, Elixogen Therapeutics, used a special protein called ZSCAN4 to treat patients with congenitally short telomeres. They successfully lengthened the telomeres in the patient's hematopoietic stem cells, with no severe side effects observed. This is the first time in scientific history that a clinical trial has effectively extended telomeres in human cells. This discovery represents a potential new key to human longevity. In the future, perhaps humans will finally be able to challenge the immortality just like the lobster. But the real question is, do you really want to live that long?